Assalamu alaikum dear students. Yesterday we discussed the concept of integration by parts, that is how we integrate the product of two functions. Now today we will continue this very topic and we will discuss some more special types of integrals. Now the first one is find the integral of e of x into f of x plus f dash of x, where f of x is any arbitrary function. So we have to find its indefinite integral. Let's assume that this I equals to integral given integral. So by multiplication we simply get integral ex fx dx plus ex f dash of x dx. Now name this first term of this as I1, that is I1 equals to integral ex f of x dx. You know by ILATE this e of x is the exponential function, which implies that it comes always related to the given function. That is, if f of x is any function, then f of x we have to take this f of x as first function and e of x as second function, because by ILATE rule. Now using that integration by parts, that is product of integration rule, we simply get f of x ex, because integral of second function is ex, and differentiation of first, that is f dash x ex integral. Now put this I1 in first, we get I equals to f of x e of x minus integral f dash x e of x plus integral e of x f dash of x. So this and this, they are same, so they will cancel. We simply get f of x ex, which implies that the integral of this type of function, that is e of x into f of x plus f dash x, becomes simply f of x e of x. Like if we consider find the integral of ex into log x plus 1 by x. Now if we put f of x equals to log x, then its derivative is 1 upon x, which implies that f of x is here log x, f dash of x is 1 by x, which implies that by above its integral is simply ex log x. Now we will do some questions from this exercise 7, that is exercise 7.7. That the question is here, find the integral of x sine inverse x dx. Now this x sine inverse dx, let we put this to be I. We know that by ILATE inverse always comes first function. This means that sine inverse, we have to write this as sine inverse x into x. So let's take sine inverse as first and x as second function. This means that by product rule its integration is simply first function, that is sine inverse x, into integral of second x square by 2 minus integral of differentiation of first, that is sine inverse x, its differentiation is 1 by root 1 minus x square, into integral of second x square by 2 into dx. So it is simply minus 1 by 2 x square upon 1 minus x square dx. Now here we can write this as 1 by 2. Now take this minus as minus x square upon 1 plus x square 1 minus x square. Now add and subtract here 1, which implies that 1 minus x square minus 1 upon root 1 minus x square, because when we cancel we simply get, by taking minus out, we get minus 1 by 2 root x square upon 1 upon root 1 minus x square. So distribute this denominator, we simply get plus 1 by 2 integral of 1 minus x square upon root 1 minus x square minus 1 upon root 1 minus x square. Now we know that a upon root a is always root a, which implies that it is simply x square upon 2 sine inverse x plus 1 by 2 integral of root 1 minus x square dx minus 1 by 2 sine inverse x. Now let's put this integral root 1 minus x square as I1, which implies that I1 equals to root 1 minus x square. Now take here 1 as the second function and integrate by using the product rule. It is first function into integration of second, that is 1, which is x, minus integral of differentiation of first. Now differentiation of root 1 minus x square is minus 2x upon 2 root 1 minus x square, because differentiation of root x is root 1 by 2 root x into integration of second, that is x. Now it is simply minus minus plus, it's 2 cancels, it is x square upon root 1 minus x square. Now using this procedure here, by adding 1 and minus, by adding and subtracting 1, we can write this as 1 minus x square minus 1 upon root 1 minus x square, because 1 cancels, minus minus plus becomes plus. Hence the given I1 becomes x into root 1 minus x square minus 1 minus x square. By distributing this denominator, it is 1 minus x square upon 1 minus x square, root 1 minus x square minus 1 by root 1 minus x square. Now it is integral root 1 minus x square dx plus minus minus becomes plus 1 by root 1 minus x square. Its integration is sine inverse x. So which implies that I1 is root 1 minus x square. Now here this is the given integral, that is I1 minus I1 sine inverse x plus c. Shifting this, it is 2I1 is this very expression, which implies that I1 equals to x by 2 root 1 minus x square plus 1 by 2 sine inverse x plus c. So substitute in main integral, that is I equals to 1 by 2 x square minus 1 sine inverse x by taking sine and sine common in equation first. It is 1 by 2. Now what is I1? I1 is here x by 2 root 1 minus x square plus 1 by 2 sine inverse x. After simplifying this and taking sine inverse common from the terms containing sine inverse x, we get x sine inverse x becomes, that is integral becomes 1 by 2 x square minus 3 by 4 sine inverse x plus x by 4 root 1 minus x square plus c. So in this way we can find this indefinite integral of any function of this type, that is whether cos inverse x into x or tan inverse x into x. So procedure is same. Now find the integral ex 1 plus sin x upon 1 plus cos x. Now we can write this as 1 plus sin x upon 1 plus cos x as by changing angle to half angle and using the identity sin square theta plus cos square theta 1. We know that cos square x by 2 plus sin square x by 2 is 1, so this means it is this one, and sin x can be written as sin 2x upon 2. Similarly here we can write 1 plus cos 2x upon 2. Now we know that sin 2 theta is 2i sin theta cos theta, so it simply becomes 2i sin x by 2 cos x by 2, and here cos 2 theta becomes 2i cos square theta minus 1. So minus minus cancels, in denominator we simply get cos x by 2, which implies that the given integral becomes, we have here we have cos square x by 2 sin square x by 2 plus sin 2 x by 2 becomes 2 sin x by 2 cos x by 2, which is a square plus b square plus 2ab, that is a plus b whole square. Hence it simply becomes cos x by 2 plus sin x by 2 whole square. Now 1 cos 2x by 2 becomes 2i cos square x by 2 minus 1, that is 2i cos square x by 2. Taking 1 by 2 common and dividing this cos x, we simply get 1 plus tan x by 2. Using a plus b square, we get 1 a square, that is 1 square 1 plus tan square x by 2 plus 2i tan x by 2. Here it is 2i tan x by 2. Now 1 plus tan square is sec square plus 2x by 2, that is 1 by 2 sec square x by 2 plus tan x by 2, which implies that the integral ex 1 plus sin upon 1 plus cos x becomes ex into 1 by 2 sec square x by 2 plus tan x by 2. Now here if we put f of x equals to tan x, now it is differentiation becomes f dash x becomes 1 by 2 sec square x by 2, because differentiation of tan is sec square and differentiation of x by 2 is 1 by 2, that is 1 by 2 f dash becomes 1 by 2 sec square x by 2. Hence the given integral, that is integral ex into 1 plus sin upon 1 plus cos x becomes the integral of the form of ex into fx plus f dash of x, where fx is tan x by 2, which implies that hence by using this very integral, special integral, we get its indefinite integral as ex into f of x, that is ex tan x by 2 plus c. So in this way we can solve the integrals of this type. Similarly, if we have ex into 1 upon x minus 1 upon x square, if we put f of x is equal to 1 by x, f dash becomes minus 1 by x square, which implies that the integral ex into 1 upon x minus 1 upon x square becomes simply 1 upon x ex plus c. So in this way we completed. You can solve, the any integrand which is of the product of two functions. So inshallah in tomorrow's video lecture we will discuss, the sums more special integrals. So thank you, which is actually exercise 7.7. So thank you.